Welcome to MNConcreteDesign. This is a brief tutorial on how to use the tools in this website. So if you have successfully logged in, this is what you will see on screen under the tools page. So MNConcreteDesign is a website on tools and information on how to design reinforced concrete sections. So this tool analyzes rectangular concrete section with one layer of reinforcement on each side of the section. The best way to illustrate how this works is with an example. If we have a slab, we may want to change this input in the geometry section. Let's say we are analyzing 1 meter wide strip by 300 mil in depth. We can change the reinforcement. For example, if we want a double symmetric reinforcement, we just put the same reinforcement, top and bottom. We can change the cover. In this case, just for simplicity, let's say that we have a uniform cover, so we tick this box. We don't have any stirrups being slab, so we put this data to 0. Concrete cover, we may want to change this, say 50 mil, and then we don't have any right or left side reinforcement. Again, this is a slab, so we have only top and bottom layers. We put the number of bars on the right and left side to 0. You may have seen that when I was updating the geometry, this image was updating and it shows your geometry. So 1 meter wide section, 300 mil deep with 4 bars at the bottom and 4 bars at the top, all being 20 millimeter in diameter. So this is quite useful because you may have entered a wrong data by mistake or a typo. So this gives you visual and instantaneous representation of your input. So we are happy with our input in terms of geometry, so we can move on to the reinforcement properties and concrete properties. So the reinforcement properties are pre-populated and they look pretty good to me. It's a steel reinforcement, so I'm not going to change any of this data. The concrete properties, I may want to change the concrete grade, for example, 40 MPa. And you can see that the modulus of elasticity updates with the concrete grade. So again, 40 MPa. You may want to override this value if you are working with another code or you have done some testing, or um, it's free to you're free to update and override any of these values. If you want a description and more understanding of this data, you can just click here and download the manual. It will open up in your downloads and you can have a look. And that manual will give you also the sign conventions for the loads. Briefly, bending moment around X is around the horizontal axis, is positive if there is tension at the bottom of the section. The bending moment around the vertical axis MY would be positive if there is tension on the left-hand side of the section, and the axial force is positive for compression. Coming back to our example, if we have a slab, so the axial load might be negligible and we don't have any bending moment around the vertical axis, we can have, I don't know, 50 kilonewton meter, and we have completed our input. So we are ready to run the software. And there are two buttons here, so SLS and ULS buttons for doing those two checks. We can start with SLS and we can click here. And as you can see, this image updates with a red hatch showing the compressed area of the section. And it populates the results box with the concrete stress, maximum concrete stress, which is positive in value, and the top and bottom steel stress. In this case, the top steel is, as you can see, within the red hatch area, meaning in compression, and in fact is positive, and the bottom steel is in tension, so negative. You also have the depth of the neutral axis and the crack width according to the AS3600 equation. Now that we have completed the SLS check, we can move on to ULS check. We just click this button Just wait for the software to run and it will give you the interaction diagram, which is the combination of bending moment and axial load in this case that define the resistance of the section. Now, being a slab, you may only be interested in the bending moment capacity. To get that, you just hover the mouse here on this point, which is the intersection of the interaction diagram with the horizontal axis where the axial load is 0. And you can read the MNX value, in this case is 135 kilonewton meter. And you can compare that capacity, bending moment capacity, with your bending moment, design bending moment, and see if it complies in terms of strength and what is your utilization in the section. Okay, to illustrate a bit more ULS checks, there are a few features that I would like to show, but I think it's better if we change the geometry and say we are analyzing a column in this case. And let's say that is 500 mil by 500 mil. We can keep the same data in terms of reinforcement. We just add a couple of bars here to make the section symmetric. Yeah, let's keep everything as is. We may want to keep the same loads. This is for, well, probably just to be more realistic, let's put like a couple of bending moment like this, and then axial force just to make it more realistic. Of a column, we click SLS check, and you can see that the software runs and it should give you again the image of the section with the position of the neutral axis, and in red the area in compression, and it populates the results field as you can see here. But the interesting thing is the ULS check. We click this button and this graph will update. Here you can actually toggle and choose different diagrams. You know, you can have the bending moment around the vertical axis versus the axial load, or the two bending moments for a given axial load. In this case, let's say we have a 1000 kilonewton axial load. We just re-click the ULS check and it will rerun the analysis, and it will give you the two bending moments for the given axial load, like this. So if I go back to this diagram, I just want to show you a feature. So once we have this diagram, we can do the checks in two ways. So one is uploading the results from our analysis. And for example, if you have an Excel spreadsheet like this, you have in X and Y, in this case, the bending moment around X, and in Y, the axial load. You have your combination of loads from your structural analysis software that you want to import in MNConcreteDesign. So you just click upload, you select your file, you click there, and you can see all the points, your points are plotted on the diagram. So if the point falls within the boundary of the diagram, it means that that combination of bending moment and axial load satisfy the strength criteria. If it's outside, it doesn't. So you need to change your design. The other way, and then you can clear and you still have your diagram. You can actually export the results. If I click here, it should open up. Yeah, so let me drag this in. It will open up an Excel spreadsheet with your points of the diagram, which you can copy and paste and use in your own spreadsheet and recreate the bending moment diagram as you wish. Okay, I think that's all I wanted to share with you. I hope that you have found this brief tutorial useful, and thanks again for watching.